This video is going to build on the previous videos, and the goal of it's going to be to help you understand how to graph sine and cosine functions that possess not only an amplitude and a vertical shift, but also a b value. We'll talk about what that means, and a phase shift. Well, let's talk about what that means. These equations are going to be of the general form y equals a sine of, usually there's a bracket or parentheses here, I'm going to put a bracket, b times x minus c plus d. So let's talk about what each of these terms means. Well, A is still the amplitude. Nothing's changed about that. That's still the exact same thing it was before. And this d value over here is still the vertical shift, and you're still going to do the exact same things with it as you did in the previous videos. Now, what about b? B doesn't really have a definition. It has one, but I'm forgetting the name, and you don't need to know for your pre-calc class. But it essentially affects the period. So I'm just going to say right here, affects the period. So in the previous videos, I said the period was always 2 pi. Well, this b value might make it different. And c represents what is called a phase shift. Talk about what that means in a second as well. So let's go ahead and just go through our amplitude, vertical shift, max, and min, and then I'll show you where the b value and the phase shift come in. So an example might be y equals 2 sine of pi times x minus 1 plus 3. Okay, so as we know from before, our amplitude would be 2 because it's just that number in the front. Our vertical shift would be positive 3. Our max is therefore the vertical shift plus the amplitude would be 5. Our min is the vertical shift minus the amplitude, which would be 1. And then this is where things start to get a little bit different. So I'm going to put them in a different color to emphasize that. So the period is no longer just 2 pi. The period is equal to 2 pi divided by the b value. So in this case, our b value is equal to pi. You can see that b right here has been replaced with pi. So 2 pi over b would be 2 pi over pi, which would give us 2. Now the x scale is still the same thing in that it's still the period divided by 4, which in this case would be 2 divided by 4, or 0.5. So what that b value does is it functions to change our period and therefore our x scale. Now the phase shift. The phase shift of minus 1 means that you're moving, right, as PS for phase shift, means that you are moving 1 to the right. So I'm going to say 1 to the right. If this sign here is negative, you are moving to the right. If this sign is positive, you are moving to the left. And I'll show you what that means in the graph. So I'm going to go ahead and draw this scale over here. And you're going to find that much of what we do is very similar. There's just kind of one major difference at the end. Okay. I've drawn it like this for a reason. You'll see that reason as I produce the graph. Okay, so just like before, the first thing you want to do is make your scales. My y scale needs to cover at least from 1, my minimum, to 5, my maximum. So I'm going to write 1, 2, 3, 4, 5. I'm not even going to worry about the negatives in this case because it doesn't need to go down there. My x scale is 0.5, so I'm going to do 1, 2, 3, 4, 5, 6, 7 lines at 0.5. I'll talk about why I did 7 when I discuss the phase shift. So that's 0.5, that's 1, that's 1.5, 2, 2.5, 3, 3.5. All I'm doing is I'm going up by intervals of 0.5. Next thing I need to do is I need to draw my lines. Well, these lines are going to be drawn at the max, which is 5. Draw them in this pink color. So that would be one line. The minimum, which is 1. And of course, my middle value, which is 3. So those are my 3 lines. Again, they're going to be dotted when you draw them. Do not draw solid lines. Your teachers will not like that. Just convenient for me right now because of the computer. Okay, now what about my phase shift? So this is something new that we haven't had to deal with before. Well, my phase shift, what I'm going to do is I'm going to draw a horizontal or a vertical dotted line. And since it's a phase shift of 1 to the right, I'm going to draw that line 1 to the right of my y-axis. So at the value x equals 1. So here we go. I got my dotted line coming in here. Now, what am I to do with that dotted line? Well, with that dotted line, I'm going to start there instead of starting on the y-axis. So in the previous examples, if I had sine, I started in the middle of my 3 horizontal lines, in this case the 3 pink lines. I would start on the middle one because it's sine, and I would start on the y-axis. Well, I'm still going to start on the middle of my 3 pink lines here, but instead of starting on the y-axis, I'm going to start on this vertical line that I have just drawn. Since it's sine, it starts in the middle, so it would be right here. Sine up, you would go to here, then to here, down to here, up to here, up to here. Again, just that alternating cycle, and you can do it the other way as well. Just kind of keeps doing that pattern. You then connect the lines as we did before. Come as vertical as possible through the bottom and as horizontal as possible through the top. And there you have it. That's how you graph a sine function when it has an amplitude, a b-value, a phase shift, and a vertical shift.